Hello, my name is Donald Choate, and I will be giving you a tour of a small simulated network that I made for CCNA I's Capstone project for CPSC 2820 at Walter State Community College. Before we go any further, please excuse the harshness of my microphone. This is a very small, probably not very efficient network, but my goal in building this network was to practice subnetting IPv4. I'm not 100% comfortable subnetting IPv4, so I thought it would be a really good idea to take this Capstone project and use it as subnetting practice instead of building a whole network practice. I mean, I built it. I focused more on the subnetting aspect of it. Anyways, we have a total of 7 devices. We have 4 host machines, 2 for each network. We have 2 2960 switches, and we have one 1941 router. Both the switches and the router have been secured with VTY, console and privileged executive passwords with encryption. All unused interfaces on the devices have been shut down, and SSH has been enabled on both the switches and the router. So what I've done is created 2 smaller networks from one major address, that address being 192.168.1.0/24, and I thought of a scenario where a client needed an address pool of 10 and then a pool of 70. So the small network, the network consisting of 10 addresses, I had to first allocate 16. That gave us 14 usable, ranging from 0.129 to 0.142 with a subnet mask of 255.255.255.240. The large network needing 70 addresses, I had to jump to the next pool, which was 128. That gave us usable 126 addresses. That gave us a little bit left over for expansion purposes if the client needed it. The range on that being 0.1 to 0.126 with a subnet mask of 255.255.255.128. The small network is running off of router R1's gigabit 00 interface, and the large network is running off of router R1's gigabit 01 interface. My big rule in designing this network was that routers and switches get the first available addresses in the pools, and that the host machines get the last available addresses in the pools. Okay. Let's take a closer look at the devices in our network, starting with router R1. Here's our first line of defense, our console password we mentioned earlier, that being Cisco. Let's head into privilege mode, password for that being class. These are all referenced over here on the side, and of course in a production environment I would never set up passwords like this. This is just for ease of use right now. Head back over here. Let's issue the show version command so we can see what our router is, what it's like. We see our uptime. We see our system image file, licensing information, device information, our configuration register. All that's normal. Let's go ahead and take a look at our running configuration. As you can see, we have our service password encryption that's encrypting all plain text passwords. We've set up our host name as R1. We have our enable secret password set up and encrypted. We've got our admin username set up, our SSH getting set up, our domain names, the descriptions of our interfaces, what our IP addresses are, details over that. We have our VLAN, no interface on our, no IP address on our VLAN. and our passwords for our different lines. Let's go ahead and take a look at our interfaces. We're going to use the show IP interface brief command. We have both of our gigabit interfaces up. Our VLAN is down. Our gigabit Ethernet 00 is running to our small network, and our gigabit Ethernet 01 is running to our large network. Let's go ahead and head over to the large network. Take a look at it. Instead of here, access this switch command line. Our password is Cisco for our console, and class for our privilege mode. Let's take a look at our version. Everything looks good here. Model numbers, serial numbers, everything's good there. Let's take a look at our running configuration. You can see we've got our host name set up, our enable secret, our service password encryption, encrypting our plain text passwords, our domain name, and our admin username for our SSH. We have our two currently open interfaces heading to our host PCs. The other interfaces have been shut down. They're not in use. They don't need to be open. It leaves a security hole. Our banner is configured. We have our default gateway configured and our VLAN IP address configured. And of course our passwords for our lines. Let's go ahead and take a look at our interface status. Show IP interface brief. Here's our basic overview of our statuses. We've got our first two fast Ethernets opened up, heading to our hosts. Everything else is, of course, shut down, except for our VLAN. Our VLAN is set up 192.168.1.2. It's good to go. Heading over now to the small network, taking a look at the switch over there. Let's go ahead and get in. Our password is Cisco for our console, and for our privilege mode it is class. Let's take a look at our version. Let's go ahead and take a look at our running configuration. We've got our service password encryption, our enable secret, host names, our IP domain name, and our admin username, and password and privileges set up there for our SSH. Our two open interfaces heading to our two host machines. The others are down for security purposes. They don't need to be up. We've configured our banner, our default gateway, and our IP address and subnet address for the VLAN. We also have our passwords on our different lines. Let's take a look at our interfaces. Our first two interfaces are up and running. They're connected to our two host machines. The other interfaces are down, all except for VLAN 1, assigned address of 192.168.1.130. Let's take a look at our host machines for these networks. For the small network, we have PC 0. IP address is set up as so, following our basic rule of routers and switches getting the first address and our host machines getting the last addresses in the pool. The same for our large network. Now here comes the real test. Let's see if we can use PC0 in our small network to ping the other devices throughout our overall network. Let's see if we can ping the VLAN on the switch. So our VLAN for our small network switch is 192.168.1 and 130. PC30. A little bit of latency going on, but everything looks good. We're able to get to the switch. Let's see if we are able to get to PC1. The address for PC1 is 141. Let's see if we can get to it. It looks like we can, so we know we at least have communication within our small network. Logically speaking, if we're able to ping from PC0 to PC1, PC1 should be able to ping back. That's probably a bad assumption. We're going to assume it. So now let's see if we can get from PC0 to our default gateway. Let's ping the default gateway for this address. Default gateway being 129. And it looks like we are able to get to the default gateway. Now let's take a break from the small network, head over to the large. Let's go ahead and grab PC2, open a command prompt on it, and let's see if we can ping the switch for the large network. Ping 192.168.1.2 being that switch's address. And it looks like we are able to get to the switch. We know we're able to get to the switch. Let's see if we can get to PC3. PC3's address being 125. And we are able to get to PC3. Once again, we are going to assume that since we can ping PC3, PC3 will be able to ping us back. Let's see if we can get to the default gateway for our large network. The default gateway for our large network being 192.168.1.1. We are able to get to the default gateway. Now, for the big test, let's see if we can ping across that router to our small network. Let's go from PC2 back to PC0. 192.168.1, and the address on PC0 is config, looks like it's 142. Oops. Back to PC2. Oops, well. We're going to pretend that didn't happen. And we are able to ping across that network. So to recap, this is the CCNA I Capstone project. The goal here was to design and implement a small business network. I primarily focused on the IPv4 subnetting as I felt I needed more practice in that area. If you have questions, comments, concerns, please feel free to leave them down below in the comment section. Thank you for your time. This has been Donald Schote showing off my network for the CCNA I Capstone project for CPSC 2820 at Walter State Community College.